Problem from the homework questions, but unfortunately I already have the answer here, so we're just going to confirm if it is correct as much as we said here it's correct. So let's read. A solid ball is released from rest and slide in a side hill from a slope down at this angle from the horizontal. That is the only thing that we're given, and now they want mu s if there is no slip. We're using static friction because there is no slip. So literally, if something, let me say this is a ball and this is a surface. A ball, when a ball is moving is moving, like rotationally moving on the surface like a wheel, relative to the surface the wheel is not moving. That's why I use static frictional force. Okay, let's not worry about that. Let's try to attempt to solve the problem. Okay, we know that also acceleration, tangential, let me just call it tangential acceleration is equal to alpha, of which is angular acceleration, multiplied by r. We know that, and we also know that torque is equals to moment of inertia multiplied by angular acceleration. So what else we can use? We know this is a solid sphere here. That means we know its moment of inertia, right? Moment of inertia formula, of which I think should be 2 over 5 m r squared. And then from this equation we can get that alpha is equal to acceleration all over r. And then instead of putting alpha, we're going to put acceleration all over r. For simplicity, let me write this r as r point r. That is good, right? That is same as r squared. On the other side, we also know that torque is equals to force and the arm. The force that is causing this wheel to rotate is the force that works like this, of which you know it to be force friction. I'll just denote it as F in this video because I think it's the only force involved here. Then here we can write friction force cross arm, of which arm is the radius. From that we notice that this r is the same as this r, and this r is the same as this r. That gives us a solution of F is equals to 2 over 5 m a. We can also look at this. We were looking at rotational motion here, so we're looking at rods here. We can look at translational motion. Okay, so we can also say sum of forces is equals to ma So what are forces? Let's go back. I didn't draw the free body. This is the slope and this is the ball. The ball has weight going this way, has normal going this way, called this weight, and weight has a component called weight parallel from high school, and we also have the weight perpendicular. So these are all forces that are involved. Also there should be a friction moving up, because I think the wheel is set to be down the slope, and friction is here, should oppose the motion. So what are forces? And I also take this x hat as positive for my calculation, down the slope as positive. So what are forces going down the slope? Is going to be weight parallel. Weight parallel is mg, its opposite sine theta. Remember that we are given theta here but I'm ignoring it, so I'll just work with theta. I'll substitute in the end wherever needed. I just want to work with theta. Okay, so that was our weight, and the other force going up was friction, but we already have an equation here for friction, right? So we can just take that equation, goes here, and that will be 2 over 5 ma should equals to ma. If I take this ma on the other side, I'll have 1 ma plus 2 over 5 ma, and if you do your math there, that should be this times this 1 plus is 7 over 5 ma's, if there's anything like that in language. So now here I have mg sine theta. On this side I have 7 over 5 ma. You can look at something that is common. I think it's this m and this m. With that, we can now get an equation for acceleration by timesing by 5 over 7, timesing by 5 over 7 both sides. Then this will cancel that on, they'll just disappear, and here we'll have 5 over 7 g sine theta. We have established another equation for acceleration. So what else we know? We know that friction is equals to normal force times mu, static frictional force. Should use an S. What is friction? Friction is given here. We already have friction. We can put 2 over 5 ma is equals to what is normal. Come back here. Normal is the same as this component is the same as this component. So this one was mg cos theta. So normal is going to be mg cos theta, and mu is just, let me just put it as mu static like this, and we're looking at something that is common again. Can I spot any? I see this m, I see this m. That's all I can see. I think I missed some substitution. Let's do it again. 5 over 2 over 5a. Here I have g cos theta mu s, and I'm looking, the m is normal, but the acceleration, we do have an equation for acceleration here waiting for us to substitute, right? So I'm copying this equation from here. This is the equation I'm trying to plug here, and if I plug it, I'll have 5 over 7 g sine theta. That should equal to acceleration. And again, I'll look for something that is common now. This 5 and this 5, this g and this g. That's good. And now I'm left with cos theta this side and mu s, and this side I'm left with that 2 and that 7, and here only sine theta. And remember, I'm trying to go back to the question, I'm trying to find the minimum value of static friction. So this is what we are interested in. So let's go back to our problem, solving for him. So we're just going to divide by or multiply by 1 over cos theta both side, multiply by 1 over cos theta. Okay, and now what are we doing? We are going to have to how do I do it? Oh, I'll just cancel this one. Why I'm doing this, I'll just cancel this one. Here I'll have mu k. Let me just put it on that side, and this side I'll have 2 over 7 and a cos. and the sine they give you what, tan theta. So we just got a formula to use. Remember, they gave us an angle. Go back to the question. They gave us this angle, so we are just going to come back here and plug the angle. And if I did press my calculator well, you will confirm with me on the comment section. I made a mistake again. This is US, mu-s, so it's static, it's not moving, right? I said that. So it's going to be 0.155442158, depending on the significant figures they wanted you to present your answer. So whatever answer that we had here in the bottom, it is indeed correct. So comment in the comment section. Also, don't forget to press a notification bar, and also tell us if there are questions that you want us to work on, especially the homework questions like this one. And please don't forget to share, subscribe. We thank you.